Today we are going to do chemistry third chapter, that is element compounds and mixtures. Now this chapter is also based on matter. The previous chapter, the first chapter that you did on matter was based on the states of it. Okay. So everything in this universe is made up of matter. All materials that you see around you are made up of matter. And matter is something that occupies space, and has mass and can be perceived by senses. Matter can exist in three forms: solid, liquid and gases, depending on the temperature and pressure. Matter is basically built of many small particles called atoms or molecules. Molecules are made up of atoms. Atoms, when they gain or lose electrons, form ions. Now, matter can be chemically classified into various categories based on its similarity, its dissimilarity, its uses. Okay, so what we'll study today is the classification of matter based on its chemical composition. So based on chemical composition of matter, it is broadly classified into two groups: pure substances and impure substances. Pure substances are made up of a similar kind of atoms. Pure substances have a definite chemical composition and definite physical properties. Okay, it is uniform. The composition is uniform throughout the bulk. Fine. If we need to study a pure substance, say, suppose I'm opening my earring, which is made up of gold. So this is a pure substance. Okay, it is an element. So if we study the earring and we study its structure, right, we take an atom from the tip or we take an atom from this side. Okay, either way, if we study this, what we'll see that they are similar. The atoms which are make up this element is similar. That is, they have the same number of electrons, protons and neutrons. So they are said to be pure substances. Now, impure substances are just the opposite. Impure substances are made up of two or more pure substances combined in any ratio. It does not have a uniform composition or a fixed ratio of combination. Okay. They do not have a definite set of properties. It is seen the compound, the substances which is mixed or combined to form these impure substances, the properties of those compounds are retained in this impure substances. They do not have a new set of properties, whereas pure substances, they have a new set of properties. Okay, so now talking about pure substances. Pure substances can be again categorized into elements and compounds. Now, elements are made up of one kind of atom. Okay, it is the simplest substance and it cannot be broken down by physical or chemical means into simpler substances. I showed you the earring made of gold, Au, which is an element. Okay, sodium, Na, which is a very highly reactive element. So magnesium, iron, calcium, potassium, all these are elements. Are the basic substances that make up any other substance. Okay, they are widely distributed in the earth. They exist as free or in combined state. Okay, they have a definite set of characteristics. Each element consists of only one kind of atoms. The atoms of each element differ in properties. Okay, suppose the properties of sodium will not match with the property of magnesium because they are two different elements. Fine. An element is composed either of individual atoms or of molecules made up of atoms. So either they are made up of atoms or the atoms combine to form molecules which make up the elements. Elements have fixed melting and boiling point. The temperature at which it boils or temperature at which it melts is fixed. Fine. Elements cannot be broken down into more simpler substances exhibiting its properties. So it cannot be, as I told you, cannot be, it is already the simplest substances found, and it cannot be broken down into more simpler substance. Elements may react chemically with other elements and compounds. So an element can react with other element like NaCl, sodium chloride, or hydrogen sulfide, or water. So one element reacts with another element to form a new substance or compound. Now, elements can be classified again into four groups: metals, non-metals, metalloids, and inert gases. Now, metals are elements which are monoatomic. They are monoatomic, they show a definite set of properties, these metals. So, they are monoatomic, they are normally solid in state, in normal temperature and pressure. They only one metal is there which is liquid. Okay, mercury, which is used in thermometers. Fine. So otherwise all other metals are solid. The metals have their own luster, that is shine. They are sonorous. If you beat something with it, it will make sound. Okay, it can be drawn into wires, it can be beaten into sheets. Okay, they are ductile, they are malleable. So these are a definite set of properties of metals. Okay, the metals are monoatomic, that if only one atom of the substance can make one molecule of it. So one atom is present in one molecule of the substance. They are monoatomic. So examples of metals are magnesium, copper. We see copper wires, isn't it? Gold, so I've already showed you, you must have seen. Silver also ornaments, very common. Magnesium, it is present in all the crackers that you burst, okay, which you shouldn't. And then aluminium foil, you must have seen at home. So these are all metals. Okay, and there are many metals more. When you study the periodic table, you'll learn more about the names of metals. Now, based on dissimilarity, there is another group of element, that is non-metals, which do not show the properties that I talked about regarding metals. So what do they show? They are polyatomic. That is, in one molecule of a non-metal, there are more than one atoms present. It is very difficult for them to exist as a single atom. Okay, suppose I take of example of oxygen. So one atom of oxygen will combine with another atom of oxygen to form O2. So oxygen is a diatomic substance. That is, in one molecule there are two atoms of oxygen present. Same with hydrogen. Hydrogen will also combine with another hydrogen atom to form H2. That is hydrogen gas. Okay, one molecule of hydrogen which has two atoms in it. So in this way the non-metals are polyatomic. They do not have their shine, they are not sonorous, they cannot be drawn into wires, they cannot be beaten into thin sheets, they are not ductile, they are not malleable. Okay, non-metals exist as solid, liquids, or gas. They exist in all the three physical states. Fine. For example, I've already taken oxygen, hydrogen, nitrogen, carbon. Very common carbon is again in the form of graphite, diamond, coal. All these are forms of carbon. So these are all non-metals. So now I am moving on to the next group, that is metalloid. Metalloids are monoatomic. Okay, elements. They show properties both of metals as well as non-metals. So there are some properties which matches the metals, and some property matches the non-metals. So therefore it is in a different group. For example, boron, arsenic, antimony, germanium, silicon present in sand. Okay, so these are all a different group of pure substance called metalloids. The fourth type of element is inert gases. So the inert gases, what happens? They do not react with other elements. Why? Because their valence shell has complete 8 electrons. They need not react. Why do reactions take place? It is because to gain the stable configuration. Okay, in its outermost shell. The inert gases already have a stable configuration. So therefore it does not react with any other elements. There are very few inert gases present, okay, like xenon, argon, neon, helium. Okay, so these are all inert gases, that is, they do not react with other elements. Fine. There are 118 elements which have been discovered. Okay, so how to learn so many names? So to make it simpler, the scientists have brought out a system of using symbols. So you must have done in your previous classes the representation of symbols. I'll just quickly just revise with you the symbols. Few of the elements, their symbols have been made by using the first letter of the element with a capital. Okay, like carbon, C with a capital C. So this is how the symbols are made of few elements. Few elements where the alphabet is common, the second alphabet also has been taken along with the first. The first being written with a capital letter and the second with a small letter. Like calcium. Calcium is also starting with C. And carbon, I've already told you, it is denoted by C. So calcium got the symbol as Ca, where C is written in capital and a small letter. Fine. This way cobalt, Co. So now coming to copper. As because cobalt is already Co, so copper name couldn't be given as Co. So therefore copper got its name from its Latin name. So there are few elements which are named from its Latin name, like sodium, Na, natrium, potassium, kalium, K, okay, copper, cuprum, Cu, iron, ferrum, Fe. So in this way they have been named from using the initials from their Latin name. So this is how all the elements have been symbolized, whether it is a metal or a non-metal. And now coming to the next pure substance, that is a compound. So compound is also a pure substance, although it is made up of two or more elements, but they are combined in a fixed proportion by mass. So as because they are combined by fixed proportion, therefore it is said to be a pure substance. Now the properties of the compounds are like the compound contains atoms of two or more elements combined chemically in a fixed ratio by mass. For example, if we take water H2O. So here what happens? Water, hydrogen and oxygen is combined in the ratio of 2:1. Fine. So this ratio, this combination is fixed, whether water you study here or anywhere else, or you take the first drop of water or the last drop of water from the glass, the combination is same. They are pure and homogeneous. All samples of pure compounds have identical, definite physical and chemical properties. So the properties of the compounds are also fixed. If we take, like we're studying water, we take the physical properties of water, it is liquid in normal temperature, standard temperature and pressure. So it is same for all kinds of water, okay, wherever it is found. And chemically, it is 2 atoms of hydrogen and 1 atom of oxygen. That is also similar everywhere. Fine. Compounds have definite melting and boiling points. So you know the water's melting point is 0 degrees centigrade and the boiling point is 100 degrees centigrade. So compounds have their own definite melting point as well as boiling point. The constituents of a compound from which it is made can be separated only by chemical methods. Now, if we need to separate hydrogen and oxygen from water, we cannot separate it by physical methods, by hammering it or trying to pull it apart. Okay, so no physical method will work for separating the components of the compound. Chemically they can be separated, like we pass electric current through water, then it may dissociate into hydrogen and oxygen, provided a little bit acid is added to it. It's acidified, because pure water is a bad conductor of electricity. Okay, the compounds have definite chemical formulae representing their molecules. There is a method of representing the compounds, the molecular formula. So you must have learnt in your previous class how the symbols are represented. The cation or the metallic ion first, then the non-metallic ion, and then the valencies crisscrossed. Okay, and written as subscript. So this is the way the molecular formula is written of compound, and it is fixed. As for water, I am using H2O, and this is fixed. It will not change. Fine. So although compounds are made up of elements of different, made up of different kinds of elements, but it has its own set of properties. Like hydrogen and oxygen are gases. They combine, but what are they forming? Water. Water is, in normal temperature and pressure, a liquid. So therefore, water as a compound has its own set of properties. It does not retain the properties of the elements with which it is formed. Another example that we can talk about is iron sulfide, FeS. FeS is made up of iron and sulfur in the ratio of 7:4. Now you know iron is a magnetic substance. A magnet can attract iron, and sulfur has the characteristics of dissolving in a liquid called carbon disulfide. Okay, so it can very easily, sulfur can dissolve in carbon disulfide. It's a characteristic feature of sulfur. But when they combine and form FeS, iron sulfide, it is seen that this compound is neither magnetic nor does it dissolve in carbon disulfide. So this also, by this we can say, it is proved that the compound does not retain the property of its element with which it is formed. Okay, some common compounds formula you need to learn. Okay, and rest, as you've already learned how to write molecular formula, and if you've learned the symbols and valencies, you can easily write the chemical formula of most of the compounds. Fine. Compounds can be of two types: organic compounds and inorganic compounds. Organic compounds are compounds in which one element that is combining is always carbon. So when there is carbon present in any compound, then it is said to be an organic compound. If carbon is not present in a compound, then it is said to be inorganic compound. For example, glucose, C6H12O6. As because carbon is present if combining with hydrogen and oxygen, therefore it is an organic compound. Now talk about NaCl, sodium chloride. No carbon is present, so it is an inorganic compound. Now let's talk about impure substances. Impure substances are mainly mixtures. So what are mixtures? Mixtures are a physically combined two or more pure substance in any ratio. Fine. So a mixture may be homogeneous if the solute is evenly distributed, or it has a uniform composition, then the mixture is said to be homogeneous. And if the mixture the solute is not evenly distributed or not uniformly dissolved, so that kind of mixture is said to be a heterogeneous mixture. So homo means same, hetero means different. So depending on their uniformity, if it is uniform, homogeneous; not uniform, heterogeneous. For example, sugar and water. Sugar and water, you can dissolve it very nicely, stir it well, and then we can form a uniform solution of it. That is a homogeneous mixture. Why? Because if you taste the first sip and the last sip has the same sweetness. That means the sugar is nicely dissolved in it, and therefore it can be an example of a homogeneous mixture. For heterogeneous mixture, you can take mud and water. How much ever you try to dissolve, it will not dissolve uniformly. So it is a heterogeneous mixture. Now the properties of mixtures. A mixture consists of two or more pure substances that exist together without any chemical combination between them. They do not combine chemically. That is, there is no give and take of electrons. They are just physically combined. That is, the particles become very small, the solute particles, and they place themselves between the solvent. Okay, they do not combine chemically, and that is, there is no exchange of electrons. The mixture may be homogeneous or heterogeneous. The composition of mixtures may vary. So I can put 4 spoons of sugar, you can put 2 spoons of sugar, fine. So that way it can vary. So therefore the proportions will also vary. Mixtures do not have fixed melting and boiling points. They depend on the properties of the components present in them. So what with the mixtures, what are the pure substances that have combined to form the mixture? Based on that, their melting and boiling point varies. Okay. The components of mixtures can be separated by physical method. Like if iron is mixed with say some sand, okay, so then we can use an iron magnet and hover over it, so all the iron particles will be stuck to the magnet and it can be separated from the sand. Or we can just separate salt from water by boiling. So by using physical methods, we can separate the components of a mixture, which we cannot do in a compound. Okay, and there's no energy change taking place when the mixtures are formed. Fine. Mixtures cannot be represented by any chemical formula. Mixtures cannot have a chemical formula.